Welcome, everyone. Thank you for joining us today. I'm Andrea Copping with Pacific Northwest National Laboratory, and I also represent Ocean Energy Systems Environmental, or OES-Environmental. OES-Environmental is a collection of 15 countries. There's 25 in ocean energy systems, of which 15 have signed up to work on environmental issues. And we examine the environmental effects associated with marine renewables, particularly as they affect permitting and getting devices in the water and moving forward with this low-carbon energy source. As OES Environmental, we have been working for almost 10 years now, trying to really understand what some of the interactions of the marine environment with marine renewable energy devices might be, the animals, the habitats, the ecosystem processes. And we have been working on a process to try to organize and simplify some of the scientific information that's becoming available. And certainly compared to 10 years ago, we know a great deal more than we did back then. And we've been sharing that periodically through TEFAS, of course. And what we're going to talk about here today is the next steps we've taken in trying to really make data available so that it is useful for regulatory purposes, to let project developers understand what their needs, what they are going to be asked to do, where there's some information available, et cetera. So I'm going to turn this over to Michaela Freeman in just a moment. Just a couple of announcements. We are recording this webinar, and we will post the slides and the audio later on. Your discussion will be recorded, but we will not post that. We use that just for our own purposes so we can understand the questions and record them and take note of them and see what we can do with any of the input. So I think with that, I'm going to turn it over to Michaela for the rest of the webinar.
Thank you, Andrea, and thank you everyone for joining us today. We appreciate you taking the time to do so. My name is Michaela Freeman, and I am a Marine Science and Policy Analyst here at Pacific Northwest National Lab, also representing OES Environmental. And I'd just like to note that we have a few other folks in our office on the phone today who work on this task. We have Haley Farr and Lene Hemry, and of course, Andrea Copping, who you just heard from. So with that, we'll get started. Today, I just want to do some quick introductions. Andrea gave you a great rundown of who we are and what we do. Then I'll talk about the purpose for the workshop and give some introductions to the topic. After that, I'll talk about data transferability and the process that we've developed. We've actually been running webinars and workshops with U.S. regulators for a few years now, and many of you guys on the phone today are new to our outreach efforts we've done, so I want to give you some background to kind of set the stage for what we're talking about. And then I will show you guys our monitoring Dataset Discoverability Matrix, which is the real reason we're here today, and preview this tool that we hope will help regulators such as yourselves to aid in the permitting process for marine renewable energy devices and also increase understanding of environmental effects. And then last, we'll end with some next steps. So Andrea kind of gave you a great background on who we are and what we do, so I won't go too much into this, but as she mentioned, we're representing OES Environmental today. We have a list of the 15 countries who are currently participating right now in the task, and we have been focusing for the past few years on these concepts of data transferability and risk retirement. We'll get into data transferability during the workshop today, but risk retirement is a topic for another time, but I just want to quickly introduce it to you. It's this concept where we want to assess the potential to retire environmental effects that may be low risk. And when we say retire, that doesn't mean we're not thinking about them anymore. It just means that when we have enough evidence that we think a risk might be low, we can decrease the amount of effort or whether or not we're looking at it in consenting processes. And if more information becomes available in the future, say when marine renewable energy goes from single or small numbers of devices to larger arrays, it may be a risk that we'll need to re-examine as more information comes about. We do have a previously recorded webinar up on our TPIS platform, which we held last year for U.S. regulators. So I will make sure to send everyone the link for that. If you're interested, you can hear more about this topic later. And the reason I introduce this is because these two processes of data transferability and risk retirement really work together to advance our understanding of environmental effects, to aid permitting process, and to really help progress the MRE industry in a responsible manner. Before we get started into more of why we're here, I want to introduce these concepts of stressors and receptors, as you'll hear me talk a bit about them today. Stressors are the parts of a device or a result of the device's function that may cause harm or stress. And through collaboration with the marine renewable energy industry and writing our State of the Science reports, both the one we published back in 2016 and our current version, which is the 2020 State of the Science report, and will be out in May of this year, it became apparent that there are 6 key stressors which have really been the focus of our work, and you'll see this throughout our presentation today. Receptors are the marine animals, habitats, and ecosystem processes that may be affected by the stressors. So to give you a quick example of this, for underwater noise being the stressor, we might look at that for a tidal turbine and how it might affect a marine mammal, the receptor, by limiting, say, its ability to communicate with others and navigate its environment. So I just wanted to familiarize you guys with this. We'll have a few other concepts I'll define as we go through. So why we're here today, there's a perception among the marine renewable energy industry that it takes a long time to get projects in the water, that permitting is long and complicated, and that there are really extensive baseline data and post-installation requirements. On top of that, we perceive that the regulatory community, such as yourself, faces lots of challenges and that there's not many devices in the water. There's new technologies that we don't know much about, and there's some remaining uncertainty about potential environmental effects. And on top of this, you're mandated to protect the marine environment, to follow a suite of different regulations and laws, and make decisions on applications for marine renewable energy projects. So we believe that by getting devices in the water, we'll learn more and can mitigate some of the challenges faced by both the industry and the regulatory community, but that needs to be done in a responsible manner. And our work at OES-Environmental has really been working to bridge these gaps and help move things forward responsibly. So by engaging with the U.S. regulatory community, as I mentioned, we've been doing that since about 2017, holding different online webinars and workshops, and also conducting regulator surveys. We started off in the U.S. and have now completed regulator surveys in UK, Sweden, Spain, Japan, Ireland, France, and Canada to get an understanding of regulators' perceptions on the industry, knowledge of the different technologies out there, and also to see what thoughts are on how this industry can move forward and what permitting or consenting challenges are. So through these engagements, it really became apparent that there was a need for sharing data between marine renewable energy projects to help advance the industry. And we believe that data or information collected through research studies and monitoring from projects should be used to inform new projects. We do recognize that at some level, site-specific data will always be needed for new projects, but that existing data should be used as much as possible. So that's where data transferability comes to play, where data from an already permitted or consented marine renewable energy project or analogous industries such as offshore wind or oil and gas can be used to inform consenting for a future marine renewable energy project. And in this case, when I talk about data, it could be raw or quality controlled data, but more likely it comes in the form of analyzed or synthesized data, information, or reports. And that's something we really heard in previous engagement with regulators, is that there was a want for data that could be easily interpreted for permitting processes. So based off these engagements, in 2018, we developed a process to guide this data transferability, which is shown in this image on the left side of the screen. This includes a framework as the focal point, which classifies these stressor-receptor relationships, as well as a data collection consistency table, the matrix we'll talk about today, and best management practices. All of these components really work together to achieve data transfer, and we've vetted this process with regulators and the larger international marine renewable energy community. And throughout it, we incorporated feedback we heard during online workshops and at international conference workshops. I'm going to give you guys a little bit of information on these different pieces today. There's also a pre-recorded workshop from last year that goes into more detail about the data transferability process, but I just want to give a brief overview of the different components, again, to set the stage for when we talk about the matrix and how that fits into this process. So the framework itself, we developed to guide the overall process and help bring together data sets in an organized manner. It categorizes these environmental interactions to assess if data can be transferred from one project to another using 4 variables to define a specific interaction, which includes stressor, receptor, site conditions, and technology type. We additionally developed some guidelines for transferability that specify what is needed. So this includes information such as the environmental interaction you're looking at needs to be defined by the same 4 variables, and that data is collected consistently so that you're not comparing apples to oranges when you're looking at transferring data. Additionally, another guideline for transferability is that you have to be looking at the same or closely related receptor species. And all of these is to ensure, again, that you're not comparing apples to oranges and that there's some consistency between the data that you're actually comparing. Speaking of collection or data consistency, we briefly developed this data collection consistency table. I'm not going to go into much detail here, but I just wanted to give a quick overview of the table. It lays out different methods for each of the 6 stressors we've been talking about, units that are commonly used for it, and then methods for interpretation and analysis. And our colleagues over at the Triton Initiative, who also work here at Pacific Northwest National Lab, have taken this initial work and have been further developing it by assessing monitoring methods and assessments to be able to provide best practices and test some of these out in sites in the Pacific Northwest of the U.S. So I've linked their website down in the corner of this slide, and I highly suggest you checking it out. Lene, who's been a part of that Triton project, is on the phone with us today, so if you do have any questions about that, please feel free to ask. And lastly, the best management practices were developed to suggest 4 practices in order to actually implement data transferability. We have a whole document we developed on these best management practices that can be found on TPIS. I'll send you guys a link to the data transferability TPIS page, which has the best management practice document and the previously recorded workshops I was talking about, so you can find more detail on this. But these best management practices lay out some guides for implementation, and in the document we have more details such as for best management practice 2, it's likely to be regulators who are determining which data sets meet consistency and quality assurance needs, as well as device developers and their consultants, whereas for best management practice 3, it's more likely to be researchers who are actually developing and providing models that can be used by consultants, and then those results are used by regulators. So the next step I'm going to go into is talking about the matrix, but before I go on, I just wanted to see if there were any questions about what I've presented so far. I know that was a lot of information in a little bit of time. So moving on to the matrix, with that background on why we developed the data transferability process and the different aspects of it, I want to focus the rest of our time on the matrix specifically. As I mentioned, we've done a lot of engagement, and after talking mostly with regulators about the ability to transfer data between projects, we kept hearing that there was a need to easily find and access data that could actually be transferred and applied in permitting processes. So we started out kind of workshopping the idea around with a larger marine renewable energy community and felt this was something we could develop. So with our partners in the UK at Aquaterra, we have worked for the past year or so on developing our Monitoring Datasets Discoverability Matrix. And it makes datasets from existing projects accessible so that regulators and the larger marine renewable energy community can transfer data for permitting future projects. And again, this is characterized by the 6 stressors that we've been talking about. So the matrix uses similar classifications as the framework, the stressor, receptor, site conditions, and technology types that you saw in the framework, but expands on that to give some additional details. I do want to mention that throughout this, we had to keep this somewhat general so that the matrix would be applicable across the board and keep it at a higher level so that this wasn't kind of just a massive matrix tree that you'll see. It'll make a little more sense when I show you in the next slide. But we hope that once more data is available that we may be able to get more specific in how the matrix looks like and some of the different characteristics we're able to look at. So for instance, right now with site conditions relevant for, say, underwater noise, you'll see something such as, is it a quiet or a loud environment? And those are different from those relevant for benthic habitat changes, which we'll be asking, is it a soft bottom or a hard bottom site? So throughout the matrix, with these different characteristics, you'll see that with each stressor, there are ones that are specific to each one, some that they have in common. It's just dependent on what's relevant for the actual stressor. The data sets in the matrix come from OES-Environmental metadata, which has been collected from marine renewable energy project sites and research studies around the world since 2012. This information has mostly been received from project developers or researchers who fill out our metadata forms, and then we publish that information on TPIS. Each metadata form is aimed to be updated on a yearly basis, and we're always adding new and planned projects to it. We do only capture projects that have environmental monitoring, and you'll see we do split out studies that people do by baseline and post-installation monitoring, which is how the matrix will kind of define some of the results, and then also research geared towards environmental studies. So the matrix itself is an interactive tool that allows users to sort through defined characteristics, choose those that are relevant to filter through the metadata, and then it provides results that are relevant for a future project. And what we aim in people using this is you have a future project that you're looking at, and the matrix is sorting through those previous or current projects or deployments or research studies that may be applicable for your application. So in the next slide, I'm going to show a pre-recorded demonstration of the matrix, and then I'll open it up online for some further exploration. I do want to orient you real quick to our matrix tool. As I mentioned, it's on our TPIS online database, which if you're not familiar with, I suggest you explore. It houses a knowledge base with tons of information on both marine renewable energy, wave and tidal, as well as both land-based and offshore wind. This tool is specific to marine renewable energy as part of our OES-Environmental initiative. But what we're looking at here is there's some background on the matrix up at the top. We actually have some instructions for how to use the matrix down below the gray box you'll see with a PDF document with some really detailed instructions. And then in the gray box, you'll see the 6 stressors up at the top. We have split out habitat change into water column and benthic. As we were looking through that, we realized that the characteristics were quite different between the two, so we have actually split those out. Once you open a tab at the top, you'll first see the stressor followed by the relevant receptor. In this case, it's marine mammals and fish, and you can see that each characteristic is marked at the top in bold, so that while you're going through the matrix, you can tell which characteristic you're looking at. To filter through the matrix, you click on the blue dots, which will open the next line of characteristics up. And once you are ready to filter and get your results, you'll actually click on the text, which will highlight that View Results button in the corner. And at any point in the matrix, if you want your results to be less specific, say just relevant for underwater noise and marine mammals, you can click the text on marine mammals, and it'll include all of the other characteristics. If you're only interested in a really specific application, then you can go through the end of the matrix, click the text, and find your results there. So now that I've oriented you guys, I'm going to play this quick video and talk through it a little bit more. So at the top, you can see we've selected underwater noise. We are interested here in a tidal turbine in a noisy environment and particularly interested in the potential impacts of underwater noise on marine mammals. In this scenario, we're not as concerned about the project scale, so we're going to click on the tidal text to view results for all project scales. Once you get here, you'll see baseline and post-installation monitoring at the top with research studies at the bottom. Again, these are from OES-Environmental Metadata Forms. And for this example, we're going to click on the CGen deployment in the UK. It takes you right to the associated metadata form and highlights the row from that specific study that you clicked on. So you can see some description, design, and methods, and results. And in this case, after 3 years of post-installation monitoring, there are no major impacts, and findings can be found in the environmental monitoring program. If you scroll up on the page, you can see the rest of the metadata form, which includes the Environmental Monitoring Program report. If you click on that, that will take you to the document hosted on TPIS, where you can find a link to the file itself and access that data from there. I should mention that with this matrix, we're not actually hosting any data, but we are making the data accessible either by providing the reports, such as this environmental monitoring program, or by providing a contact name. And if you're logged in on the TPIS website, you can access an email for that contact as well, so that you can email them and get the actual data sets or more information if that's needed. As I mentioned, at the bottom of the page, we have some instructions for how to use the matrix. We also have a more detailed instruction document down at the bottom, which we'll actually are adding to that instruction document to make sure it actually follows through the process all the way through the metadata forms. I should mention that part of us presenting this matrix tool to you guys is it's not yet available publicly on TPIS. Only those who have the link can actually access the tool. So the tool is in the presentation, which will be up on TPIS, and then I will send you guys a follow-up email that has the link. But the point right now is to talk to regulators who might be using this and get any feedback on the usefulness of the tool if you think you might be able to apply it during permitting processes. And we actually talked to UK regulators early in the week and ran through the same workshop with them. And so we're very excited to hear all of the feedback from both our UK regulators and all of you guys in the coming weeks as you guys get more time to kind of explore the tool. And we did hear really great feedback on Tuesday from our UK regulators. Okay, with that, I think I'm going to go back to the actual presentation. If you would like me to look through the matrix further while we're on here to explore something else, please let me know and I can switch back to that. But I just want to ask some more pointed questions. We would love to know your thoughts on data transferability. Does this seem like something that you could apply using data and information from another jurisdiction to apply in your permitting decisions for marine renewable energy? Also, we're curious to know if the matrix makes sense to you, if you could use it during your permitting processes, and then general feedback on the matrix itself. And I should mention that since we're kind of in the early stages of the industry across the world, the matrix, we hope, will become increasingly useful as more devices go in the water and more data becomes available. So we're really working on making sure we capture all those project sites, test sites, and research studies that are going on. And as the industry progresses, there will be more and more data available through here, and it'll be hopefully easier to transfer that data and use it for permitting processes. So as I mentioned, I'll be sending a follow-up email in the next several days that will provide you guys with a link to the matrix. It would be wonderful to have each of you take some time to explore the matrix and then provide any additional feedback to myself by March 17th. You can email me there at michaela.freeman@pnnl.gov, and you should all have my email addresses as well from the webinar or workshop invite. Once we get feedback from both UK and you guys, the U.S. regulators, we will work to incorporate that feedback in the matrix, and then we will hold a public webinar on TPIS to fully unveil it. We do release what's called a TPIS blast, which is a biweekly email containing industry news, relevant journal articles, and an announcement. And so we'll make sure to announce that public webinar through our blast. If you aren't signed up already, you can go to tpis.pnnl.gov and sign up for those biweekly blasts. I assume that the public webinar will be very similar to what we've presented you today, but we, of course, would be happy to have you join that as well. As far as next steps for OES-Environmental in general, as I mentioned, we've been focusing on risk retirement as our other concept here. And as we were developing the data transferability process, we realized that it was really a key component in the ability to retire risk as we learned from previous projects and are able to use that information for future projects. We can then start moving towards retiring risk for different stressors. We have a recording, as I mentioned, from last year's workshop we held for U.S. regulators. If you're interested, I'll also make sure you guys get a link to that risk retirement TPIS page, which houses the outreach and engagement efforts we've been doing. And in 2019, we focused on the ability to retire underwater noise and electromagnetic fields at several international workshops with different experts in the marine renewable energy community and received a positive response from that. During 2020, we're going to focus on gathering the evidence base for habitat changes and changes in physical systems and assess the ability to retire those risks. And there will be a chapter in the State of the Science that will be on risk retirement and data transferability that will go into more detail about what that process looks like to gather the evidence base and the feedback we heard. Right now, we're focusing on developing guidance documents for each of the stressors that will allow the application of risk retirement when permitting projects. Our hope is to make one document for each stressor that's general enough to apply internationally with associated country-specific documents for each of the OES environmental countries. And the goal here is that these documents can be used by regulators to aid understanding and gauge the ability to retire a risk for projects with small numbers of devices. So please do be on the lookout for those things. We've been doing outreach and engagement with U.S. regulators, I think, since 2017, and we plan to continue to do this because, as Andrea mentioned, we need to make sure that these processes we're developing are useful and that they're vetted with the community that will actually be applying them. So with that, I want to thank you all for joining us today. We really appreciate you taking the time. We look forward to your feedback you have on the matrix as you get some more time to explore it. I put mine and Andrea's emails up there if you want to get in contact with us. And I'd also like to open it up for additional questions or feedback at this time.
If we have no immediate questions, this is Andrea. I just asked Michaela to go back one slide because I would like to actually make an appeal here. When Michaela says we're going to create some guidance documents, we recognize that what we've done so far is pull together the available science and those analyses that have been done for permitting purposes in other places, or some in the U.S. But we would like to make this as useful and as accessible as possible for the regulatory community worldwide. So what we are hoping to do, and we've sort of started on a process, is create a simplified document that classifies this kind of information in the major types of regulatory decision-making all of you need to make. Some of you work on species at risk. Some of you may be more spatially based, looking at things like habitat changes and so on and so forth. And we are trying to put that together in a very generalized fashion, and then for each of the participating countries have that built out a little more as it applies to the country-specific regulatory process. But we are researchers and policy people. We are not regulators. I am really looking for regulators who would be willing to engage with us as we do this, because this is your field, not ours, and we would really love to have some people who are willing to review what we're doing, sort of interim products, sit down with us and discuss what is important in making this kind of information available. Is there even a need for this, that kind of thing. So if anyone on the phone would be interested in engaging with us, we'll try to be very sensitive to your time. We would really like to have you work with us. So if that's of any interest to you, perhaps you could drop us an email. You can go to the last slide, Michaela, with our emails on it. We really would love to have your expertise and your eye on what we're doing, so we're not creating things that are useless or detrimental.
All right. Well, with that, thank you again very much for joining us today. I'll be sending you all a follow-up email with some of the links that I mentioned, as well as the link to the matrix. So thank you for your time.